Gotta set up attendance next. Hello, Lisa. Cool avatar. I didn't know they did that. That's cool.
I miss you, Tyler.
Cool, cool. All right, so you're a little bit early. You get the extra credit already. 4 minutes till we begin class. Class starts at officially 10:10, from my understanding. So 4 more minutes. Welcome back, Angel. All right, so we're about to begin. We're gonna get through our norms, and then we're gonna jump to today's problem. I'm gonna try allow so we don't have burnout. We don't have students getting tired looking at the screen. Try to get minutes of like 5 minutes in between to catch up. I might say here's 3 minutes. Try to catch up. Please use that time wisely, because sitting here and trying to catch everything, been informed, it can tire some people out. Okay, so let me start this. First and foremost, hello all STEM majors. Welcome to class. STEM stands for what? Who knows? Who knows what STEM stands for? You put it in the chat and tell me all about it. But what does STEM mean? Let's see who just came in the room. Oh, Leah Mims made it to class. Welcome to class. All right, so we're about to go through our norms. Let's get this out the way. And I got to do attendance again. We got students coming in at the buzzer. Okay, so it was Lisa and Angel who were here that got the extra credit. Okay, Jacqueline's arrived. Who else just popped up? Aaliyah did too. And you guys, you made it on time because it's the class starts officially at 10:10. So great job. I can extend the first 5 minutes before and the first 5 minutes afterwards as a means of getting extra credit. I was also informed I got to get you guys a syllabus so you'll know what to expect at every turn in these classes. These are STEM classes. They're like science graduate courses. So let's try to get you guys jobs, and you got to follow directions. The only thing we'll be doing is typing up the document, and the class has started. So let me get out of this. I was doing attendance. See, that's why I was over here in an attendance screen. Now, who is this? So everybody logging to Edsby. I'm trying to, oh, that's Courtney. Okay. See, I was like slowing down my speech so I could catch anybody that was coming. So Dixon has arrived. All right. So I'm giving y'all the first 5 minutes. I used to do 10. If you come in that 5 minute window, the first 5 minutes before class and the 5 minutes after class, you get the opportunity to get extra credit. All right. This is my way of trying to help you guys get on track. Um, So let me go through the roll call. Londe Allen is not present. Lisa Brown is present. Jacqueline Camacho is present. Mario Carvajal is not present. Christopher Clark's not present. Cordy Dixon is present. Where's my people on Google Meet? Oh, there they go. Yeah, I was like the list of people in the room. Uh, Garcia is not present. Romel Lee is not present. Rashad Larkhart is not present. Angelique Llewellyn. Oh no, she was here yesterday. She's not present at the moment. Aaliyah Mims is present. Angel Ocasio is present. Taki's Stickpin not present. Wallace not present, and Monet Worthy is not present. So goes the roll call. All right, so let me expand this. If you haven't done it already, you want to be logged into Edsby. The class is physics, right? So you should be in your physics class. Is where we at. Couple of quick reminders before I jump too far ahead. Need more people start coming to Townhouse. There are opportunities that moving forward the staff want to share with you guys, like internet services, my block, and I'm pretty soon going to be trying to get you guys in the chess and other programs to help you keep your mind off what's going on. So try to make it a Townhouse. It's a lot of positive things going on with different bulldogs and what they're trying to do to keep the culture alive at our school. Okay. So that link I'll try to keep posting, but it is a link that's going to be static, I think. It is not going to change yet. So you can use that to always get there. Next is the login to get to class. You might want to bookmark this link and just name it physics class. So you're not, some students like, I can't find a link to get to class. So bookmark. How do you bookmark something? You come up to, I don't know which browser you're using. You come up to your options and you find something that says bookmark and then bookmark this tab. I'm human, so I bookmark a lot of things in case I got to go back and review them. You might want to do the same with your classes and things you think are important on the internet. All right. So let's get to the meat and bones of today. And that is this part. I'm going to have we haven't done our norms, haven't we? No, we've not. All right, let me go back and put that in the chat, but let's go through the norms. Okay, because I want to give everybody time to be here, and I'm seeing it's 10:15. That's 5 minutes. All right, so let's see who's in here. Aaliyah Mims, can you read number 1 and 2 of the norms? Can you see it? Is your microphone
Yeah, no, right turn never.
okay? But you gotta read 1 and 2, Leah.
Oh, you said one and two. Education are sacred.
Thank you, Miss Mims. All right, Angel, can you read 3 and 4?
We will never behave or discredit ourselves, our school, and our family. At Excel Academy Southwest, students always a lady or a gentleman.
All right, I'll read 5. So we take pride in Excel Academy of Southwest. The 5 academic norms. Mr. Dixon, can you read number 1 and 2? Courtney, you there?
We respect the opinions of others. We respect the culture of the classroom.
Thank you, sir. Jacqueline, can you read number 3 and 4? Oh, your microphone is still down. Is that what the case is? I think I remember that. Oh, we gotta get that fixed. So, Lisa, can you read the rest of them, please?
Yeah. We are attentive and participate. We have high expectations of ourselves, our peers, and our teachers. We are here to focus on preparing ourselves for post-secondary endeavors.
Thank you, thank you, thank you. All right, so everybody sees Lisa's icon. She's been a great help. So if you need help, reach out to her. She's gonna make you work for it though. So just don't think she's gonna give you anything. And please don't, Lisa. Don't make things hard for yourself. All right, so I need let's see here. Courtney, you're very articulate. Could you read what's in the chat starting with hello? I mean, it's in SB, everybody, but I wanted to see if Courtney can read that.
Hello and good day to all future physicists. Please remember that all secondary problems need to be completed and ready to present tomorrow in class. Asynchronous problems have to be completed as homework and will be checked tomorrow in class as well.
Thank you, sir. So I wanted to pause there for a quick second. Does anybody have anything they want to share for extra credit? This is what we've been reading it, but I don't think you understand it. And I think one person, it might have been Courtney or somebody, they presented what they did yesterday and got some extra credit. So does anybody have any work they want to show right here, right now? And when I say share, you have to share your screen. So anybody? I've been putting it out there, just seeing if y'all don't take advantage of it or not.
Hold on, I gotta refresh it.
You got to refresh.
Yeah.
Okay. Okay. So you want me to stop sharing and you got something oh, she's got to come back. Okay. So how about this? 2 minutes to get your Google Docs set up. And if no one is ready to share after Lisa, we're just going to start on the problem and the simulations we need. Okay. So we need 2 minutes. I think I'm going to stop sharing in a moment if Lisa starts sharing. And this is like how you get points. What'd you say, Lisa?
I was gonna ask, share what?
Okay. So did you do yesterday's assignment?
Oh yeah.
That's what I meant. So when I be like, oh, in tomorrow's class as well, that means you have a moment to present it. So
Okay.
you have that ready or no?
Yeah, I just gotta go
Oh,
to it real
okay,
quick.
cool, cool.
You want me to do it right now?
Okay, yes, ma'am. I didn't know if you was ready. I'm gonna stop sharing, and you share your screen.
Okay.
So I hope everybody's paying attention. The reason I'm doing this is to showcase student work. We're going to be making our own Google Classrooms pretty soon, and you have to teach certain topics. Thank you. Good, you did a great job. Yep. See how things are crossed out? This is awesome. Thank you for putting that in the chat, Mr. Dixon. Very good. I'm gonna see if you can read it to the class in a moment. Okay, so Lisa, you did awesome. That's all you guys. I'm saying you have to do. She took yesterday's work, completed, turned it in, and then she gets extra credit for being able to share that she completed it. I don't know
Oh.
how else I can help you guys. So you start there, Lisa, and then I'm gonna let Mr. Dixon, when you're ready, can you read what you put in the chat for us? Because he's telling us, all right, man, let's get into the
Okay.
problem. I can see that right now. Okay. And Courtney, can you read in the chat what you put? All right.
Um, how much time is required for an airplane to reach its takeoff speed of 79 meters per second? If it starts from rest and its average acceleration is 8.79 meters per second.
Very good, sir. Thank you. All right. So, well, yes, it's the second power, right? Because it's squared. But you got it right. So everybody's going to pretty much do what? We got to start with our Google Doc, right? This is computer science earlier today. I'm going to hide this screen. And we're going to make sure we select what we need. All right. We want to make sure you're in your Google Drive or your Gmail account. Go to your docs. I think this is how Lisa pulled up her old work because she was quick with that. Go to blank, start a new document, right? And then name it. Okay, a lot of people are not naming documents. They come over as untitled something something. I'm taking about 5 points off of that. Not me being petty, is making sure you're ready for the real world. So what is today's date? That's the 6th of October. Well, we lost Jacqueline. So hope she comes back. And once you hit enter, it saves it automatically to the cloud. The next thing is you need your title, your header. So that's your name, not my name, but your name. And then the date again, the 6th, October 2020. Period number 2, right? Second period. And you guys are physics with algebra students. You just put physics. I know a lot of people keep forgetting to put the with algebra part. But if you look it up on your transcripts, when you get out the class successfully, they'll consider that a STEM course or a science course where you took on physics. It's just the algebra part makes them understand you understand some algebra. Okay, so and thanks for the second question, Courtney. He's helping you guys out. You're going to take both questions and put them into your Google Doc. So thank you, Mr. Dixon, for that. Now, who knows what today's title is? I'm just trying to get you guys started. And by now, you have a rhythm of what I'm asking you and what's expected. To get about 15 points, you just have to tell me what today's topic is, and that was Lisa. All right, thank you, Lisa. So she just gave us that one right there, right? Look in the chat if you don't see it. That goes in the middle of your page. How much time to get up to speed, right? And in this term, I don't want you to get confused. You just say get up to speed, but I wanted you to understand acceleration mostly because we talked about acceleration yesterday. Welcome back, Jacqueline. She's on a different. Okay, your screen looks different. All right, Courtney gets points too. Yeah, he does. Courtney knows what he's doing. That again, I got to explain this to you guys about. I'm gonna have to come to a Bulldog meeting and explain y'all roles as far as learning assistance and how it helps your scores. All right, but Lisa, you know more about it because you were one last year, and Courtney, you should remember. But anyway, what was I about to say? The next thing is called what? The word of the day. And Courtney, I'm trying to get to the point where Courtney is. Great job, but I think people are not getting the exit slip done. So let me type that in there. And I don't know if you guys remember, the exit slip is worth 25 points, right? The plus 25 points. That's towards anything you might be pretty much missing from Monday to now. I pull those up, and if it's like every day you have an exit slip done, that's 25 points, another 25 points, another 25 points. That adds up to 100 points, right? That could possibly recover one assignment. So when I'm asking you guys to get certain things done, it's to help you. It's not to, stress you out or put more work on you. It's to help you because progress reports are coming out. All right, so let's see here. How do we do this next part? How do we get the exit slip points? Well, we need two terms. We need the classroom term. And I'm going to blow this up so you guys can see it because I was trying to get the questions, but Courtney already helped me out with that. So 150%, you should see something better. And you need your classroom term. So classroom term of the day, it changes every day. And try to stay with whatever it is you're learning with these terms is put that there. And if you didn't pay attention to what Courtney put in the chat, we put this in the center because it's where it's supposed to be. What did he put? He put in the brackets instantaneous acceleration. That's why Courtney gets points, Lisa. He kind of know what I'm about to say next and everything. So I can let me hurry up and catch up to him because I don't want to lose his attention. All right, so acceleration, and that you have to find a definition for. Use Google, like put that word in there, find a good definition. Make sure it's a physics-based definition. Don't come up with no weird stuff. You might not get all the points, right? And then the other word of the day is what today? Who knows? Who is in townhouse? What is the word of the day throughout the school? Word of the day is, all right? So if you know, you can put it in the chat and get 10 points. But honestly, what you need to do is make sure you have it for the 25 points. But participation points, if you know what it is, you can tell me. Now, I want to get to Courtney's part too. I'll tell you what it is at the end of class if someone reminds me, but that's how you get your 25 points, both of those definitions. So let's take the first question that Courtney gave us. All right, I'm copying it from the chat, or you could take it from Esby, like he probably did. You're going to put that in there. Now, I want you to definitely fix this power of two. This is about making sure your reports look neat. So you have to put with the caret is what's called caret hat or extending a mathematical operation. sometimes called or. You have to use that because in ESB you can't use the subscript and superscript like I've been teaching you guys to use. So once you put in your document, make sure you correct that. That is raised to the power of 2, just like I have here. And I'm gonna for a moment I'm gonna blow this up some more because I think that's at font 10. Let's change that to about 14 so you see the difference, right? So you need to have this much typed up, right? But don't forget you have one other question that Mr. Dixon gave us. And that 2A is your asynchronous problem. You need to copy that from the chat. And I'm literally there's no way to get lost. A lot of people, I got lost. No, there's no way to get lost. Just do what I'm doing so you can at least set your document up. That way, when I go through the problems, you're not all over the place trying to type things up at the last minute. You're with the class. Again, I got another situation with okay, this is average second. This is a different question. So there's no more subscripts or okay, that's good. So I'm gonna space this out some. And then you have notes I'm gonna give you in a moment. Okay, so I'm gonna start you off with typing this much up because I think this helps. Your known and unknown. Now, be ready to put notes before this because that's usually how I do it so you can understand where the unknown and unknown values are going to go from the problem. Start thinking about, I'm going to give about 20 points to the person that gets it right. What are the values in the problem that go to the known section and what are the values that go to the unknown? Once you try to figure this out, and if you're not sure, use Google to look up a good calculation of what average acceleration is. We'll put that in the chart. I'm sorry, put that in the chat, but we talked about this a little bit yesterday. Think of velocity, but then there's an equation for, wait, she said how much time to get up to speed? Okay. I'm just looking at the chat. Sorry, y'all. Yeah, both Courtney, okay, Courtney got points, Lisa got points. They're in the chat working it out. So wait, Courtney says 79. So you talking about the 79 meters per second, Courtney? Like, where do you think that goes? That is one, but what is that going to be in your calculation? Look up the average acceleration equation. I can do it for you, but I want you guys to start using the internet better to find resources to do these problems. Okay, so I'm gonna give you about 10 minutes. No, I'm gonna do 5 because we got a lot to cover. 5 minutes, and then we're gonna share out how much we have. You should have the document at least set up. And what do you think the known values and unknown values are? Courtney gave us a clue, but I'm asking them, what part of the equation is that? You can't just put 79 meters per second, right? So what is that? What is meters per second? Use your notes from yesterday. No, gravity's not used here, Leah. We're just talking about average acceleration. You're close though, because acceleration is measured meters per second squared, right? So what you got to understand is, I think, which part of that problem would be your acceleration. So take it one step at a time. And meters per second is measured as a what? Starts with the letter V, if you remember. Oh, okay. That's meters
Velocity.
per second, right? She yelled that out. Hurt my ear. But yes, velocity is meters per second, Lee. So that's one of them. But if you remember yesterday, we had an initial velocity and a final velocity. Wait. Hold on. What is this? Lisa comes up with something. Change in velocity, change in time. Yes, ma'am. Very good. She's absolutely correct about that. So I'm going to put something in the notes. I think it's correct. This is the objective for today. And I'm going to start sharing these objectives with you guys. But Lisa said what I said a little bit shorter. So you will have at least 10 extra points to try to catch up to Lisa and Courtney if that is also in your document. Quick timing, Lisa. I'm looking at the clock. That's called using the internet correctly.
So it's like the same problem from yesterday.
What do you think?
I gotta look at the words.
So what's unknown here?
You said unknown?
What's unknown?
The time, right?
Yes, Courtney said it, Lisa. Sorry. Yes, it's the unknown value of delta t. If you remember delta, we talked about it last time, right? So that means we're going to do some quick algebra, right? Hint, hint, letting you know in advance. Get your fingers ready. So I know when we do the algebra, it helps some people to write it down, but you still have to type up the steps. If that helps you, go grab some paper and make sure you're trying out the steps. Because the goal is that when you take this test, you don't freeze. You set your knowns, your knowns and unknowns up, and then you begin tackling the problem systematically and like a scientist would. All right, so I think I'm going to stop this because I'm going to jump into this problem and get it out the way, right?
Mr. Tyler, you can move the timer out the way because I can't see.
Okay. Does that work?
Yeah.
Okay, cool. So what are we talking about? I said the known and unknown values. Anybody want to share what they think the values are in the chat? No? Okay. Going once, going twice. All right, so I guess I'll go through it. So here's some known values. What we need is some background knowledge. And I told you if you have this objective that I put in there, like this will help for your notes. I'm just going to give you guys the objective so you'll understand and have this at the forefront of your mind when you're doing the problem. Okay, so in the chat, Lisa pretty much said it. She says average acceleration is equal or equivalent to the change in velocity over the change in time. What does all that mean, right? Mr. Tyler, what you mean, right? All right, so let's put that in the chat. We can put that not in the chat, but in the document. What you gotta understand is average acceleration is in fact this equation, but let's make it mathematical now, right? So we're gonna say average acceleration, right? How do we say that? Yesterday we said that was AV, right? Or was it AVG? I think it's AV. Got me looking. So it's AAV, but you gotta make the AV subscript, so it's drop down a little bit because that's how it's written mathematically. So it's kind of close to the same, Lisa, but not exactly. I think yesterday we was dealing with just the velocities, right? But I could be wrong. We'll take a look. So once you subscript that, you come back and turn that feature off, and it's equal to what? So this is all 10. I don't know if y'all can see that. There we go. Zoom in some more for you because then leave it like Hill can't see. All right. So if I come to the center of the document, I want to center all these notes so you know what's important as far as how to tackle the problem, right? So basically, Lisa gave us the definition of average acceleration. We just converted mathematically to change in is delta, if you remember from yesterday. So you come up here, you hit insert, and you come down to your special characters, right? So once that loads, you're gonna click on arrows because that's the category you're in, math. And then you want to select delta. So it's DELTA. TA. So you got to type. It's a Greek letter actually known as delta for change in math. So you got to click on that once, and it should, there it is, give you the delta, and that's going to be V. This is going to be divided by what? Well, change in time. That's what she was putting there. Change in value, right? In each one. That's what delta means. So we're going to take this delta here as well. I'm going to come over here and place it there. And this is for time. All right. So what does that mean, right? Well, let's continue. What's inside of the delta? Remember I told you guys that you have something called a V final and a V initial. For final and initial, that's what the delta means. So that simply means it changes to, parentheses, your final velocity, VF, minus your initial velocity, VI, close parentheses. So what is this going to turn into? Pretty much the same thing, but with respect to time. So parentheses, that'll be TF minus TI, close parentheses. Okay? So it looks similar, but just be careful if you're using velocity average or acceleration average. Some of those letters will change, and some of those values will change with those letters. And I want you to be very careful when you're doing these problems on quizzes and stuff, so you know which tool to use as a physicist. All right. Down one so you can see that. Now, what does that mean in terms of the problem, right? Well, we can use pretty much this part of this equation to solve for delta t, because we don't know what delta t is. That is time. So what we're going to do is we're going to use probably this part of the equation, but let's look at how it starts. It says how much time does it take or is required for an airplane to reach its takeoff speed of 79 meters per second, right? So you need takeoff time, meaning there is, well, not takeoff time, but you need a starting speed, right? So if it starts at rest, there's a clue there. And I keep telling y'all guys, what is initial if it says starts from rest? The problem is saying it. It's 0. Kind of like Courtney. If you got out of your bed, if you never got out of your bed, what is your speed? His speed will be 0. He's at rest. So let's keep going. So we know we got to use two types for the VF and VI. Initial should be probably 0 because at rest. Final will be the number that Courtney Dixon gave us. We're not going to worry about using this form of delta. We're just going to say delta t to do the algebra. So let's write in our known values, right? They gave us what? They gave us VF, and we got to fix our VFs and stuff. So you fix that by making sure it's mathematical. Drop that down. So I can't expect y'all to do it if I don't do it myself. And drop this down. There we go. So this is actually making it how it should look. And the reason I'm having you do this with practice is if you take the SAT or any type of test for college and stuff, or even the ASVAB for the military, they'll have you look at these little funny characters. If you didn't practice getting used to making these characters, it'd be hard to identify them. Okay, so I'm gonna change this again. Just turn it off and equals, this is VF equals what? Well, Courtney told us that's 79 meters per second. Now, meters per second should just ring in your ear as a velocity. I'm gonna come back and do the dimensions for you guys in a moment. But let's take care of the problem. So it's 79 meters per second. Well, we got a VI we got to deal with, right? So, because we're just plugging all this in when we need to do the problem. VI is given as, it started at rest, right? Equal to 0. It's a lowercase 0. I gotta fix it. And an equal sign. Look, I gotta turn that thing off. I'm like, why is it down there? There we go. Stop playing with me. So 0 meters per second, right? And it's because it's at rest. That they're at rest. Yeah. Let's keep going. What else did the problem give us? Roll up a little bit. It says, and its average acceleration is 8.79 meters per second squared. That's your average acceleration. They gave it to you. So what do we type? We come here. Remember, I gave you this nice way to write average acceleration. We're going to say, hey, another known value is this. So I hope everybody's keeping up. I mean, I'm literally giving you the notes and you have to retype them so you can tackle the asynchronous problem. Because it's pretty much similar. You might have to do no algebra. But if you understand how to set up your known and unknowns, the problem falls apart. So what was the value they gave us for average acceleration? 8.79 meters per second squared. So I'm going to just take this from here because I already typed it up. I mean, this is me being like Sherlock Holmes and just piecing the problem bit by bit back together. Okay, so we have that. We have that. And now the last part I've asked everybody is, and I think Courtney and Lisa might have said it, it's time. So we're going to do some algebra to get time by itself. And we're going to call that delta t here because we don't know TF or T. We can just say, hey, we're going to figure out what it is by doing algebra to think backwards to what that might be. And that's all scientists do, is they make approximations based off the laws of physics to figure out everything around us. So that's going to be in seconds. And we'll see how it gets to seconds after it comes out of meters per second squared for acceleration and after it comes out of velocity after we do the algebra parts. So let's do the algebra parts, right? So I really want to, I think this might take some time explaining to you guys, so I'm going to go slow, but I hope we can get the simulation in because I want to show you the velocity simulation. If you've already bookmarked the link from yesterday's simulation, you can go ahead and take a snapshot, and I'll tell you what to take a snapshot of in a moment. But if you have it, you can start it up. So I'm sorry, I know for some of you guys, the simulation runs slow. So strategy, what are we doing here? So again, we're going to use algebra to solve for the change in time, right? That'll be our delta t here. Okay, so let's just put it there so you know what we're trying to get by itself, right? So let's come down. I'm going to take the equation I'm going to use, and I'm going to show you how the equation looks for you. So we're going to take this part. Remember, I'm not going to use TF and TI because we don't know what it is. So we're going to solve for it with just delta t. This means that. So we copy this and put this part of the equation here. But like I said, I'm not going to use this version, right? I'm going to use the delta t once again. Now I'm ready to begin trying to solve for the final time. Okay, so what do? Well, we got to do some algebra, right? So bring this over here and put it on the workbench. Next, I'm going to copy this equation once more, come down a step, and get ready to start getting things by itself. Now, delta t, or time, is in the denominator. So we got to get it out of the denominator and then by itself. Okay, so let's go through it. The things I want to change around here is I'm going to multiply this entire equation over here by time because delta t is already being divided. So I'm going to multiply, and then, like I said, I'm going to multiply it by itself to first get it out of the bottom, or the denominator. Okay, so these are the changes, right? Let's make sure that gets set up for you guys so you know what changed from equation to equation. I'm multiplying both sides of the equation by time. The reason you do that is because it will cancel out the time that's on the bottom of the inner fraction if you set up your system the way I have. So it's in parentheses because that's all one unit, and that is a change, right? So we got to keep going because now we got to cross some things out, right? Okay, so what are we working with so far? What crosses out? Well, all this goes away because delta time divided by delta time is just 1, all right? So I'm going to cross that out. All right, and then this goes away too because it's just a small parenthesis that was keeping it together. And we have a new equation now. All right, so I could delete all this jazz now. Okay. And that's not a new equation. So now we need to actually get time by itself. And then, well, you see what we have to do. We have to divide by average acceleration. So what I'm saying is delta t is still not by itself, it's being multiplied. So what I can do is I say, hey, put these in parentheses, and then what I want to do is I want to get average acceleration away from the time. So I'm going to take my average acceleration and I'll put that in the bottom because I'm going to divide by that on both sides of the equation. So that happened there, and it'll also happen here. And now we have average acceleration being divided on both sides of the equation. So this is the change from here. Let me just fix that up for you guys. And that was not really a change anymore. Okay, so you can get the understanding of what happened. Okay, so that was not a change either. That was just a step. Right, so now you got a better understanding. Now this also changed the previous step as well. And I kid you not, we're almost through. So when I did that, what happens, right? I'm gonna come here and we're gonna go one more step down. And what do we got? Well, we got to cross out some things. So what crosses out, if we come over here and take a look, this average acceleration that divided will cancel out with this acceleration over here. So let's cross it out. And then what crosses out as well is all this right here. So now we got an entire new equation. Let me just clean this up real quick for you guys. That's a step you have to have. So I want you to go through the iterations as engineers and physicists do. They go through steps or many steps to see how something works. So this is the new equation now. Now, all we have to do really is begin by putting in our values to finish this off. So let's try to work on this. Okay, this is Mr. Overdyke, sorry. All right, so let's try to finish this off for you guys because it's what is it, 10:48? It's almost time for townhouse. Yeah, it's getting close to that. Okay, not townhouse, but TGI. As we get out of here at like 11:10, we're almost through. Let's go to the top, and we didn't get to the simulation yet. And we're gonna put in the values, right? So the first value that we're gonna put in is, I'm gonna take this one more time and just put in our known and unknown values, right? We'll find the unknown, but we have to put the values in. So the first one I think was Courtney told us 79, and it was meters. You put m/s if that helps you, and because that's a lot of typing, I know. And then for this one, it was what? It started from rest, so that was, if you looked at your known values, that was 0 meters per second. And what was our average acceleration? I'm gonna go back up here and look. That was 8.79 meters per second squared. Okay, all right. So we'll put here 8.79, and it's meters per second. And what happens to this is you put a 2, raise it by selecting it, and use subscript, and there it is. So now something is going to cancel out, and we're going to go through that real quickly. So what do we get? Well, we know that this is going to go away because it's just 0 there. I was just following the actual math proof, and you have to do that in science because they don't like people cutting corners, to be honest with you. So then the next thing is this second squared, since it's being divided, will lose 1, and you'll just have seconds. The meters will stay downstairs, and they will cancel with the meters pretty much here by the 79. So what else cancels? Well, you have this meter here that cancels. And you also have this power of 2 seconds that goes away with that second. So that goes away down there because it's going to be -2, right? Or the 2 is going to come upstairs, and then this seconds is going to stay downstairs in the denominator, and it'll cancel this down. So it'll be 2 minus 1 in terms of exponents. So we can cross this out as well. And then well, all that's left is the 8.79 that will be pretty much combined after it divides into 79. And you won't have meters here anymore either, because that canceled with the meters in the denominator. So let's cross that out. Okay, so what is all that going to look like in the end? Well, I told you at the end it's going to pretty much be seconds, and I just explain why. Clean it up for you so you understand completely what you're dealing with. All right, and this is going to be in seconds now. Okay, so now you got to understand it, and we just calculate this last part, and we're pretty much done with this problem, right? Just cleaning it up. That's all I'm doing. And if we go up to where we're at, we wanted seconds, right? So basically, did we get that all right? I want to make sure it was 79. I was looking at the 8.79 stuff. Okay, so what is that going to be? Well, just pull up Symbolab, right? Or Google. That's quicker. I don't know which one works for you. But that's going to be this here, right? So I'm going to take, to do it in Google real quick, you can copy what you want to calculate and then open a tab, and basically you want to put the equal sign first so it can get in calculate mode, and then paste it there. So that comes to about 8.99. And let's say that's what, seconds? So the final answer is 8.99 seconds. Right? So that is the final answer at this point for getting this far. It is 10:53. Did you need me to scroll up? Did somebody miss a step? Because I was gonna talk about the simulation next. I didn't want to jump to another screen and y'all like, hold on, I didn't get a chance to take a picture or something. How you guys doing in there? Jacqueline, you there? I'm looking at the couch. Leah, you got your camera off? Angel, you there?
You scroll up.
Lisa, you good? I've been told about when y'all got that going. You just gotta say I'm here. You said scroll up.
Yeah.
Angel, there's Angel. Okay, I see the top of Angel's head. All right, scroll up to here or what?
Yeah, right there.
Okay, Leah, are you there? No problem.
Yes.
Okay, y'all should be trying to get this done. It's 10:54. Again, we get out of here at 11:10. So what I'm gonna do is I'm gonna give you 5 minutes to catch up. Tell me to scroll up, scroll down. But I really want to talk about the snapshots you need for the simulation of this part. So
Can
after
I
this
just
5
take a
minutes,
picture? Oh, sorry, my bad.
you say you'll take a picture?
Yeah, of the bottom part.
Okay, so let me scroll down.
Thank you.
Okay. So like I said, where was it at? Oh, hello, Mr. Irvin. You dropping off the link today? All right. So what was I saying? Oh, the simulation, right? You're gonna go to FET. I hope you guys have all the notes so far. And inside of the FET sim, so it's going to PHET simulator. To come to sims, and I was telling you guys yesterday how to go through these sims and figure out what you need to use. Yesterday we was talking about motion, right? So if you just click on motion, you'll come to what you need faster. Now, I think last time we was doing, which one was it? Was it this one? This forces in motion and stuff? Because I wanted you to understand acceleration. And I think this works better for you guys. Yes, it was. So I wanted you to work on.
Mr. Tyler,
Yeah, go ahead, sir.
I'm having some trouble. I can't get your chat to come up. I don't even see your presentation. I don't know what's going on my end, but it is Mr. Borders Day, so it's just one link today. If you can grab it, I don't know why I can't grab it or why I can't get in your chat.
Sometimes you gotta refresh your computer because it does that to me.
Yeah.
But just put it in the chat. I should see it.
No, I can't even get the chat to populate.
Oh, okay. So wait. Did you email it to me or no?
I can.
Yeah, I mean, but you said it's Borders because see, there's a lot of Borders links on the calendar.
Yeah. Okay, I'll send it to you.
Okay, if you do that, I can share it with the class real quick. And
Okay, All right,
Okay,
thank you.
no problem. What was I about to say to you guys? So while he gets that, we can go through this sim real quick. And all I really wanted you to focus on is make sure you had all of these turned on. Now, some people did it, but I need all these values turned on. And we're going to add a lot more friction this time. So I want you to take a picture of the amount that's needed. I'm kind of cheating for you because I want you to focus on sum of forces. You need to take a picture with the box being pushed, and you see how much force is going away. Now, on Earth, there's something called gravity. Aaliyah mentioned this. It was close, but we wasn't talking about average acceleration when we talking about gravity. Gravity is a measured value on Earth. So if you jump out of a plane, you're coming down at that same speed, and until you pull your parachute, hopefully, at the measure of gravity. Okay, so give me a minute. I want you, give me a second to grab the GGI link, but I want you guys to go to acceleration. Let me put this in the chat so it can speed you up on getting the snapshot. Now, the next question is, Mr. Tyler, how do I take a snapshot? You guys should know how to do this by now. So let me close this right here. And if you notice, okay, I got to close that. There's another one coming. I knew it. So if I click on FET right here, thank you, go away. You got screenshot. You take that, it'll download, and you put it into your Google Doc. You need to have what I have on the screen done, okay? So let me grab my emails.
Which one is this again? Is it emotional for net force
You talking about the sim?
acceleration?
It's acceleration,
Yes.
Lisa. It's acceleration.
Thank you.
No problem. Okay, I got the link for Mr. Irvin. Let me put this in the chat for you guys. And again, please participate because we talk about you guys, and if we know there's students that are worthy of, some more credit or just a little more help, because they've been.
Anything been good about me? Y'all be talking about me? Because I know I'm always popping.
Here she go. Here she go. I'm looking at my screen. That must be Aaliyah, huh? Okay.
Yeah.
Yeah. Welcome back. Where you been at though?
Yesterday I got my check, so I was thirsty, and then I
You was thirsty.
on my get fixed, so couldn't join because I was gonna be distracted, and there was too much noise in the back.
Oh boy. Okay, you gotta do better. Aren't you a senior?
Shut up, Michael.
All right, so you need to work that out, Aaliyah, because you can get them scores up. Progress reports are coming out. But otherwise, I'm glad you're back.
She been helping me catch up.
Who, Monica?
Nah, Lisa.
Lisa? Oh, goodness. She said me too. Yeah, Lisa's on top of all of it, guys. Y'all need to be making her your best friend. Again, she's not supposed to give you the answers. So if she pushed back, don't get mad. I told her not to do that. But she can't give you clues. And the same thing for Courtney. He knows a lot of stuff. I just need him to turn some work. But otherwise, yeah, you got a couple of people in here that can really help you do it, and they're veterans. So I put the link to GGI. It says the link is hyperlink in blue. It said GII, no GGI. At least Ags. Okay, I don't know what you mean. At least ask HRU first, though. Okay.
I mean, how are you?
Oh, okay, right. So when they contact you, don't just come for, hey, do this for me. Start with how are you? So make sure you have the Google Meet link for GGI today. Copy that down. Last thing is, what was today's word of the day? Who knows what that was? Well, I'll pull up my calendar and make sure I tell you the right thing. I think it starts with a C, right?
Don't mean take advantage of or something?
You said take advantage of it, but what was the word?
I don't know. I know it means take advantage of.
But that's close. That's close. That's close. So let me see if I can grab my calendar. Because in 5 minutes we're gonna share out, and then we're gonna get ready to get out of here. Well, actually, I should say 4 more minutes. We start a clock. So we're gonna share our screens. If you got something done, you'll be leaving a little early. If you have nothing to share, and be sitting here with you to show me something, or it's time to go. But please try to get this done. You need a Google Doc set up. You need something plugged in there. As far as the work we've done today, if not all of it, but a good portion. And also, you need to make sure you have the snapshot of what I have on the screen for you. So try to get a snapshot of that set up the same way. So you're ready. This is October's word list. It's coming up now. And what is the magic word for today? Okay, I'm seeing something. There we go. So it looks like the word for today is capitalize. All right. Capitalize. So I put it in the chat for you in case you didn't know, but you put that in your Google Doc, like the one we've developed today. And at the very beginning, I said there's an exit slip. Use the definition. I kind of gave the definition away, and Lisa did too, of what was it? Capitalize. In order to get those 25 points for your exit slip today, you need to make sure both definitions are written in your Google Doc with it. But you got till 8 p.m. to finish this assignment, you all. So capitalize. She left again. Uh-oh. That's what Lisa was getting at when you have to take advantage. That's one way of saying it. But you could say I'm capitalizing the letters on the keyboard, I don't know. Or the letters in my document. Let's see here. It's 11:03. I was gonna start a timer, but we're getting closer to the end. So I'm gonna stop sharing. I'm gonna call on each and every one of you to see how much you've gotten done. You just have to share your screen, see if you got the basics of the document set up and the question, both the questions in there, and one of the questions almost done. I gave you the notes. So Angel, can you share your screen for a moment? Let's see how far you've gotten. Mr. Ocasio, are you there? The screen like froze. All right. Let's see. What about you, Jacqueline? Can you share your screen? Jacqueline, are you there? It's like the couch is not moving. All right, Lisa, what about you?
Yeah.
All right, let's see what you got.
Okay.
Dang, you got the snapshot and everything. Dang, Lisa, you showing off. Okay. So do you
No.
All right, so do you think you could are you able to do the second problem? Because we're almost out of time, or you got it?
Yeah.
Okay, give it a try. Don't skip it, because I need you I need you to understand things. All right,
Okay.
Jack, I'll see you later because I know you gotta get to GGI. Jacqueline, are you there? Yeah, respond there. I'm trying to see what happened to you. Jacqueline. All right. Oh, I did set a timer. Jeez. All right, all right, all right. I hear you. Yeah, I know. GGI. Jacqueline, are you there? All right, I'm gonna have to reach out to her. You gotta type something, Jacqueline, or try to respond. Go to share your screen.